When we think of the last frontier, we usually look up, towards space. But what if I told you the most alien world, the most hostile environment we know of, isn't millions of miles away? It's right here, on our own planet. We're talking about the deep ocean, a place of absolute darkness and crushing pressure that we, frankly, know less about than the surface of the moon. Today, we're going to dive into the incredible machines we build to go there for us. And just to set the stage, let this number sink in for a second. 95%. That's how much of our own planet's ocean is still a complete mystery. It is, without a doubt, the last great unknown, Earth's final frontier. So that leads to the really big question, right? How on earth do you even begin to explore a place like that? A world where the pressure is so intense, the cold so extreme, and the darkness so complete that it's instantly lethal to any human. Well, the answer is pretty simple. We don't go there ourselves. Instead, we build these amazing robotic avatars, explorers tough enough to be our eyes, our hands, and our labs down there in the abyss. The whole solution really boils down to some of the most advanced robotics ever created. And these are way more than just simple drones. These are incredibly sophisticated survival machines, and they mostly fall into two main categories. Okay, so on your left, you've got an autonomous underwater vehicle, or AUV. The best way to think of this one is like a pre-programmed scout. You send it off on a long mission to map the seafloor or gather data all on its own. Now, on the right, that's a remotely operated vehicle, or ROV. This guy is a total workhorse that's tethered to a ship and piloted in real time. So you've got a trade-off, right? The AUVs give you incredible freedom and can stay down for ages, while the ROVs give you the power and precision of direct human control. And the specs on these machines are just wild. The Freedom AUV can work at 6,000 meters. I mean, that is nearly 4 miles straight down, and it can stay down there for up to half a year. Meanwhile, the Quasar ROV is an absolute powerhouse. It's what they call a work-class vehicle, and it can do really complex construction and repair jobs at 3,000 meters. These things aren't just observers. They are literally deep-sea construction workers. But here's the thing. The real genius isn't just in the big robot itself. It's in all the little innovations, the countless tiny details that let these things function at all in such a ridiculously extreme environment. I mean, just think about the basic problems you have to solve. How do you plug in an electrical cable when you're surrounded by salt water that's corrosive and loves to conduct electricity? The answer? These things called wet mateable connectors. A total game changer. And, well, how do you see in pitch blackness? You use sound. Advanced sonar systems that literally paint a picture of the world around you. And I love this quote from Dr. Jim Cairns, one of the guys who helped invent that connector technology. He said, "The problem wasn't the electrical connection itself, but trying to make it happen in seawater." So his solution was just brilliant. Instead of fighting the water, he designed a connector that pushes the seawater out of the way with a non-conductive oil right before the electrical pins touch. It's like creating a tiny, perfect oil-filled bubble for the connection to happen safely inside. That one idea changed everything. But, and this is a really important but, this relentless push for innovation comes with a huge warning sign. When that drive to go deeper and use new materials gets way ahead of careful testing and oversight, well, the deep ocean is brutally unforgiving. And the story of the OceanGate Titan is just a heartbreaking example of this. For years, the company used subs with proven steel hulls. That's the industry standard. But then, to get to the Titanic, they switched to this experimental carbon fiber design. The first hull cracked. The second one, which was built by suppliers who had no experience with this kind of craft, catastrophically imploded. It's a stark, brutal reminder that in this frontier, proven engineering isn't just a good idea. It's a law of survival. So, the technological risks are obviously huge, but they're not the only ones. And that brings us to an even bigger challenge, the ecological risks, the danger our machines pose to a world we are only just starting to understand. Now, this quote here might sound a little academic, but it boils down to something really simple and pretty scary. We just don't have a reliable who's who of life in the deep sea. Our scientific catalogs are full of blank pages. And if you don't know what's there to begin with, how can you possibly know what you're destroying? And that's where this crucial idea comes in, the ecological baseline. It's a fancy term, but all it really means is taking a super detailed before picture of an ecosystem. Because without that before picture, there's absolutely no way to know if our activities, whether it's mining or just exploring, are causing harm. You can't measure change if you don't know what normal looks like. So right now, there's this incredible race against the clock. Scientists are scrambling to build up these libraries, creating DNA barcodes for species, making image databases to train AI to recognize creatures. One of the coolest tools they're trying to use is called environmental DNA, or eDNA. It's like CSI for the ocean. They can just take a water sample, and from the tiny bits of skin cells and waste floating around, they can tell what species live there. It's a way to figure out who's in the neighborhood before it's too late. And all of this sets up the fundamental question, the big dilemma for the future of the abyss. We have these unbelievably powerful robotic tools. The question is, what are we going to choose to do with them? It is so important to remember that the machines themselves are neutral. They're just tools. Whether they become these incredible instruments for discovery and wonder, or tools for industrial exploitation, is a choice that's completely up to us. And you can see these two very different paths perfectly right here. On one hand, these robots can be our greatest archaeological tools, connecting us to our own history. And on the other, they're the essential workhorses that power our modern world. For example, take the discovery of the USS Nevada. This historic battleship was found almost 15,500 feet down. At that depth, the intense cold, the total darkness, and the lack of oxygen means it's perfectly preserved. It's a time capsule. And these robots let us visit and study these incredible pieces of history without ever disturbing them. And then you have the industrial side. These work-class ROVs are absolutely vital. They build and maintain the massive undersea infrastructure for the energy sector. The pipeline inspections, the repairs, they're doing the critical work that keeps our global economy humming along. So this is the question we're left with. We are finally standing at the doorway to Earth's last frontier. We have built the machines that can open that door. Are we going to use them as tools of wonder and careful discovery, or will they become weapons of exploitation in a fragile world we barely understand? Because in the end, the technology won't decide. We will. As we use these robots to peer into the deep, the reflection we're going to see looking back at us will be our own values, our own priorities. The choice is entirely in our hands.
Like and subscribe to my channel.